to be constantly jumping back and forth between like Ruby land and JS land, just because you understand and you know Ruby. And so we're going to go into like how something works, and we're going to dive into the language. So the first thing is going to be, right now I'm just, huh?
No, it's Chuck Downfield.
Oh yeah, it's your boy Chuck Downfield and Matt the Slayer, right? Very good. And so we have like just Chuck Downfield and Matt. And so right here, this is just a regular Ruby file, right? You can see it says .rb, and it's about scope. And so here it's just a method that says def say name, and all it does is it puts name. So far, so good. So how do I run this file? You have to call say name? Cool. But let's actually run this file. So here, how would I run this file? Boop, 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 boop. Yeah, so I would just put ruby scope.rb. And what should I expect to see? Nothing, right? So how do I call this? Do I do this? Say name with the bananas? All right, I can. They're optional. And so what do I get if I run this? Who thinks it's going to be old Chuck Downfield and Matt the Slayer? Who thinks it's going to be something different? Rutrow, undefined local variable or method name. And so name right here doesn't actually exist inside the scope of this method. Oof, embarrassing, embarrassing. So how do I make that happen? I have to pass in the name variable. This is going to take in some sort of argument, and then I just print the argument. Right? So, poop, poop. And there it is, old Chuck Downfield and Matt the Slayer. Cool. So what do we understand right now in terms of scoping? Right? Ruby needs variables passed in for their methods to be able to understand and retrieve them. If it's not currently defined within the scope of the method, it doesn't actually exist. So let's take a look at JavaScript and do this exact side-by-side comparison. Cool? So if I were to do something like var name, and I were to put entertainment cheese. I don't know why you guys don't like this. It's one of my favorite things to say. Yo, Matt, do you have like a cool nickname?
3 Bigos. Part 1. 3 Bigos.
3 B. All right, Charles Entertainment Cheese and chicken nuggets and fries. This is what he ate for lunch. That's a healthy diet right there. So if I needed to build this like similar functionality in JavaScript, how would I start this? Do I put def here?
Function.
Right, I need the function keyword. And so you see this highlighting, plus plus the editors, right? So function, and what do you want to name this? Say name, right? This time without the camel case. And do I need the bananas here?
Sure.
Okay, great. And that's just about it, right? If I were to say something like return name, what would I expect to get? Interesting. Okay. So again, how can I run this file? How can I test this? Can I just do JS and then index.js? No. It's in the browser. Yeah, it's in the browser. Very good. So I see I have an index.html file, and this thing pulls in the script file index.js. So I should just open my browser. Boop. And there it is. I can always check the console. There's nothing in there, smart. So let's take a look. Ready? I have this name that I'm declaring, and I have a function. Now what do I need to do? So will this work? Nothing. Okay. What do I have to do? This is right now is just a reference to the function. I have to invoke it by putting the bananas in. And so if I do that, okay. Interesting. Old console log, embarrassing. And there it is. I see Charles Entertainment Cheese and chicken nuggets. Why is it that this worked? Oops. But this didn't. Right, and so now you can start to see the little differences. So Ruby, inside the scope, inside of a method, looks within the method. JavaScript will do what is known as an outward lookup. So it will always go out. So for example, right? Is there a variable called name declared inside this function? No. And so it will start to look outside the function scope to see, is there something declared on the next level out? And so right now, I'm inside a function, right? So the scope inside this function is here. If nothing exists here, it will start to look out. And so we can fix that by simply saying, by declaring another var name. And now I can put, all right, does anyone want to be in this bit, bad boy? All right, we'll put your boy in here. Cool? And so what should I expect to see now inside the console? Right. Because what it first does is it looks up right here, hey, is there a variable called name? And then if it doesn't exist, it looks outside, right? It will keep doing this, right? As you start to get really nested, it will always look outside. And so that's why in Ruby, how can we fix it so that this works the same way as this? Not exactly interpolation, but you ever seen this before? What happens? Right, I'm basically creating what is known as a global variable. So it should exist in all scopes. And so that's why when you see JavaScript just declaring variables on what is known as like the global, there's nothing nested inside this. And so in Ruby, we don't really say that. Like initially, this is not necessarily a global variable. This is a local variable. But here, we'll say that this is a global variable because it's available everywhere because of the way it looks up. Everything's going to look up outside eventually till it gets to the global scope. So anything declared here will in fact be just global by default. Yeah?
If you wrote the name below the function, it wouldn't show it.
You're talking about this?
Yeah.
Whoops. My shortcuts. Yeah. I'm tracking. You mean talking about this? And then you want me to get rid of your boy, right? Okay, what do you think will happen?
I'm guessing
So how come, right, this, even though it was declared afterwards, it still has access to it?
It wasn't new. It's not what it's kind of, it loads the file first, then like it's gonna go through the form, it's gonna find what name is, and then it like goes through and when you call say, oh no, say name's called.
Here? So what happens if I were to do,
Say name above.
what do you think? It still works. What about this? What if I do this? Boop, boop, boop. And then I pass in name. What will happen? Undefined local variable name. So here's what happens, right? Ruby will read your code, right? Top to bottom, left to right. JavaScript will also do this. JavaScript is a single-threaded programming language versus Ruby, which can be multi-threaded. And I'll talk about that offline if anyone wants to know more about that. But it is single-threaded. It can only run one process at a time, and it is non-blocking. The problem is this. JavaScript will do what is known as like two sort of read-throughs of your code, which is different than Ruby. Ruby will just read it top to bottom. The second it sees this, it's going to go, oh, great, you're trying to pass in something called name, but name doesn't exist because it's defined and assigned and declared on line 7. So here, right, and this is what I want to get into this next topic, it's JavaScript does something called hoisting. Does anyone know what hoisting is? That's what it sounds like. That's what it sounds like. It's a little tricky.
Like it holds, like it finds variables and then like it knows about it. So I guess when it's second pass, then it's like hoisted up. It already knows about it, or it starts running anything.
Close, close. So JavaScript does this. It does two read-throughs of your code. The first thing it does is it just reads it and stores everything into memory. So top to bottom, left to right, it'll go line 1, oh, cool comment, bet. Line 6, it'll see this function keyword and just like, great, I'm going to store this function into memory. So now I have this function called sayName in memory. 13 is an execution of that function. Cool. And then line 14, it goes, okay, there's a variable called name that's declared right here. And so all I'm going to do is memorize the fact that there's a name here. We'll talk about var in a little bit in terms of like what it can and can't do. But then it basically runs through all your code and it's like, oh my god, line 213, cool, got you fam. And then it will go back and it will do what is known as the execution phase. So it'll see that there's a function that's declared here, cool, I already put that in memory. And then line 13, it will actually execute this line. So does the variable name exist on this line when it's executing on line 13? Yes, it exists in memory because of that first read-through. And so JavaScript is a little bit different. And we're going to talk a little bit more about that. And we're going to get specifically diving into like hoisting. Cool. You had a question or just stretching? All right, got you, fam. All right. Cool. Any questions on like how Ruby does scoping? That was like all easy, right? JavaScript's bizarre. And that's okay. Look at that. Powerful. So we put all these examples in the README just so you can kind of look at it later. But let's actually talk a little bit more about, you guys don't want this, right? Cool. Let's talk a little bit more about like scopes. So Ruby does scoping differently from JavaScript, obviously, that you can see. And the idea is that there's three main scopes. There's what is known as the global scope, which I already kind of explained, and that is anything that's defined directly against the text editor. So like right here, there's nothing, this is not nested in anything. So if I had a variable name, this is on the global scope, versus this variable name, which is inside what? A function. So this would be function scoped, right? If I didn't have this, could I console log name here? No, because it's inside the function. And so, boop, boop, boop. Right, so now we have function scope. If you declare something within a function, it's only accessible within that function and anything nested inside that function. So JavaScript is weird, and we're going to talk a little bit about this. But this function, does this function currently return anything? No. So what if it returned 7? What would this whole function do? Well, it would declare a variable, it would console log it, and then it would just return 7, right? Like a G. But what it can do is it can also return another function, which is bizarre. Don't worry, it's going to be okay. In the same way that, what can this return besides a number? Can it return a string? A string of lies. What about an array or an object? Right, the idea is that functions are what in JavaScript? They're just objects. So it can, in fact, just simply return a function. And that's sort of like the logic to think through. This function also has its own scoping. Right? Whoops. Oop. Own nominate over there. Do you know? All right. I'm just a Kingdom Hearts loser. So, huh? All right. So what's going to happen here on line 13? What's it going to log? Nominate, right? Or, all right, fine. Something easy. There we go. You're welcome. Cool. What's it going to log? All right. If this didn't exist, what should this log? Your boy. Exactly. Because it will look outside. So this function is actually inside this function. And so this has access to name. Right? So that way that function lookup works. All right. Cool, 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 cool. So the last thing is something what is known as like block scoping. So does anyone know what like a block is? Yeah, this block is just literally just any like curly boys you can think of. Boom, right? Key, right? Here is block. Kind of looks like an object, but the idea is this is a block of code. So in the same way that Ruby kind of does it, where you can do something like here's an array, and then you can do dot each, do. So there's two ways to kind of do this. You can do the do end block, right? And you could pipe in a number. And then you can do like num whatever. Or you can do on the array. And you ever heard of something like the iterators takes a block? So this is a multi-line block. Then you can also, I believe it's like just straight a block of code, right? Num. You don't need to do? None of that action, and then num, like whatever you want to do. So this right here is a block of code. And so in JavaScript, we have the same thing. It's just a block of code. So right here, we have a block, and something inside that block cannot be referenced outside that block. So where we've seen blocks of code that are pretty popular are if statements. So if a particular condition, execute this block of code, which is just slightly different from functional, from like a function, which is like the function keyword and then the curly brackets. Cool? So we have global, block, and function. Any questions on like, who feels comfortable understanding like the way scope is in JavaScript? You good? What's up? Oh, all right. Yeah, your hand went up right before I said that. All right. Cool. Let's actually get into varlet and const, and then we'll dive into like the nuances, and then ultimately talk a little bit more about scoping, hoisting, since you understand this. So here's what var is, right? There are three main ways right now to declare a brand new variable. In JavaScript, if I were to do var, there's var, let, const, and then there is absolutely nothing. This right here is attaching itself to like the global object, which we'll talk about later. But if I'm trying to declare a variable, I need to prepend it with either var, let, or const. Otherwise, it becomes global. For example, inside this function scoping, right, we have this var name. If I get rid of var, what happens? It's now global. I should have access to name outside of this function, and we don't want to do that. And so that's why it's important to add var, let, or const. Otherwise, you're always declaring a global variable. So, man, is it like the lunchtime sleepiness? Are you guys all right? Yeah. It's probably because you watched this lecture already, and then you're like, now I have to sit through it again. So, all right, cool. So, var, here's what var is. var can be reassigned and redeclared as many times as you want. So here's an example. I have var and I have software engineer coach. Oops. And I can put old Chuck. Cool? So this right here, var sec, this is the declaration. So if I were to kill this, what is sec right now? Sec is undefined. I've simply declared the variable sec. I haven't assigned it a value yet. So sec, I can simply reassign the value and say mat. And so now what is sec? It's just mat. I can reuse var on sec. So I'm redeclaring and at the same time reassigning. So your boy. It's like LaCroix, but better. Cool. And so there's no error. So if I were to check out sec, I see your boy. Let's take a look at let. All right, so I can do let, and I can put, I don't know, just, you guys have any variables or nouns, people, places, things? Tomato, very good. And so I'm going to declare and assign at the same time. So what do you want this to point to? To what? Potato? Potato. This is an interesting class. Chuck Downfield? That's Charles Entertainment Cheese. I don't know who you guys are talking about. So I've declared and assigned at the same time. So if I were to take a look at tomato, what do I get? Right. Tomato, right? Obviously. If I were to re-declare saying let tomato equal to something, what would you want this to be? Oh, Stephen Master Blasta. All right, cool. What do you think will happen? Yeah. It says the identifier tomato has already been declared. So with var, I can redeclare and reassign as many times as I want. With let, I can only declare it once, but I can reassign it as many times as I want. And so in order to reassign, I can simply say tomato is equal to, okay, steakums, right? So I can reassign it as much as I want, right? It's what's for dinner. Cool. So let allows me to declare one time and reassign as many times as I want. Let's take a look at const. Cool. Do you guys have anything? Any variables? It's fine. Squirrels, right? We have squirrels. And let's just make this an array for fun. We have Alvin, we have old Theo, and we have Simon. For those that know who I'm talking about. Great. Are they though? Are they? Yo, hold on. I'm almost positive that. Oh, dang. I'm pretty sure they're a type of squirrels. Chipmunks. It's a popular question. They're different species! Oh man, I done goofed. Embarrassing, embarrassing. Oh no, what can we do now? It looks like we need to redeclare, right? So let's check. Let's take a look at squirrel. I can't believe I spelled that wrong. It's equal to something else, right? Something else. Womp womp, right? This identifier has already been declared, okay? Let's take a look at squirrels though. And they're no longer Alvin, Simon, Theodore. They are now police? Bruce?
Bruce the squirrel. Yeah.
Oh my God! Oh my God! Yes, I remember Bruce. Wow, from that movie that we all saw together at that day. Uh-oh, womp womp. So I cannot reassign or redeclare. So I can only use const one time, which makes sense because it should be a constant. So if I were to do something like var and I'd have like strong, and I let that fly, it should be fine because it's going to be undefined. And it's fine because I can probably reassign it later in the same way that I can use let, I don't know, Brandonian. All right? I can reassign these variables, but can I reassign a const? So no. So it's missing an initializer in the const declaration, which makes sense because I can always reassign the vars in let. If I don't immediately assign the const, I can never reassign it. So by doing that, essentially it's worthless, which is why it'll throw an error. So who's feeling all right about var len const? Cool, what's the difference? That is one of the main differences, yes. Spelling is correct.
So you can only define where you have to define it, and you can only define it once. You can't change it. Let, you can change it as many times. Or excuse me, var, you can change it as many times as you want. Let, you have to, or you can only define it once, and then after that you can reassign it.
Yes. So var is declare and assign as many times as you want, right? It's a little bit loose, you know what I'm saying? And then let, you can only declare one time, but you can reassign as many times as you want. Or const, you can only do one time. Cool? So there's more details to it. Var is not block scoped. So we talked about block, right? Let's see another example of block code, right? We have a for loop. So I have var equals to, you guys can help me out with this, right? Var I equals to 0, and then finish that expression. And then I have some sort of array. Cool. And what do I need with this array? Dot length. I think it's like this. Array dot length, something like that. What is it? Yo, I'm not gonna lie to you, man. I'm terrible at this. I always just do this. Boop. Oh, thank you, Jesus. Right. It's the variable, right, when it's less than that condition. So, boop. You have the variable I. Bloop. Finish the expression, the old I++. You like that trick? It's kind of dirty. And then all this is going to do is console log I. Cool? So if I let it fly, what should I see? 1, 2, 3? Array start at 0. Embarrassing. Embarrassing. Cool. So what is I right now? If I were to ask for I, what should I get? 3. Because remember, it does the I++, it comes back to the expression and is 3 less than 3. No, and then it breaks out of the for loop. That's how that's working, right? But it's terrible that now I have this I sort of like on the global. Like did I want to create I? I kind of wanted it just contained inside my for loop. So if I were to do something very similar, yeah, let's try let. I'll do old let, and then instead of I, I'll put J for fun. I'll do J, do a little J++, and then I'll do a little console log J. So what should I see? 0, 1, 2. But what is J? Oh. J is not defined. So var is not block scoped, meaning inside this block, var will escape and exist. Versus let, which is block scoped, will remain inside the block. So just so you know, const is also block scoped. But would const work at all here? Why? That's right. If I do a const to a variable plus plus, it'll be like, yo, dog, chill out with that. You cannot reassign it. So for your for loops, you should be using let. Huh? All right. The other thing var does is var hoists. So let's talk about hoisting, which is kind of bizarre. If I were to do something like var happy is equal to, you guys like emojis? You know, look at this sun face. Oh yeah. And then I would console log happy. What should I get? Sun face? Let's find out. What the? Oh yeah, it's a string. Ugh, embarrassing. Amateur. Boom. I see a little sun face right there. He or she is, right? I don't know. What does the sun have a gender pronoun? Probably not. Okay. Huh? Yeah, let's not do that. So just sun, S-U-N. All right. What happens here? No. So here's what's happening. So what I mean by hoisting is, remember JavaScript does that 2 reads. The first thing it does is it will read console log, but console log is a method that is it being invoked, yes or no? Yes, it is. There's the bananas there. And so in the read through, the first part, it'll be like, great, you're invoking this function, pass on that. And then it will see this var happy. What if we learn about var in terms of the amount of times we can reassign it? It's like infinite, right? Like one of this moves. So does it make sense for your computer, for the engine to be like, oh, you can reassign that as many times as you want? Should I save it to memory right now? Because what if you just var happy later on? And then you assign it to something else? I'd be doing double the work. I simply see var and I see happy, and I stop right there. I know that there's a variable, and it may or may not be reassigned later. I will wait until the execution portion before I actually assign it. Because var is dirty, yeah?
So basically, when you say var happy or something, it's not just saving the memory.
It's saving the memory that you're declaring a variable named happy, but it's not actually saving the value. So that means that in the second run through, right, in the execution, I'm on 34 now, and I'm trying to log, I'm executing the log. What is happy on line 34? It should be undefined because I simply have the memory of the variable happy, but I haven't saved the value of it to memory. So what it's doing, hoisting, is actually moving all your variables. It looks like you're moving all your variables. It's not actually doing this. Var happy like this. So that you have access to them so that your code does not break. In case you attempt to use a variable that's declared after it has been declared or assigned. So this is the phenomenon of hoisting. This is what's happening. Who feels like I understand hoisting? All right, so one more time. It reads through the memory, right? And it just assigns it to memory. Does not save the value. So in the second time, the execution, it was just like, cool, I know what happy is. But happy doesn't have a value, so it's undefined at this point. So var will hoist. Let and const do not hoist. What I mean by that is, if I were to do something like this, what do you think will happen? It cannot access happy before initialization. So let does not hoist. It doesn't actually have it available in memory before it is declared and assigned.
So why, I thought we reading like through the first time, so it's
It does.
saying not having value, just taking.
It understands that it's there in the memory, but because we use the let keyword, it doesn't allow you to access it before this is initialized. So right now I'm trying to access it on line 35. It gets initialized, assigned, and declared on line 40. Whereas if I used var, it'll just give me undefined.
And if you use constant, it's still, if you even though that never changes.
Yes. Let and const do not hoist, but var will hoist. Who feels better about hoisting? Okay, I'm gonna give you the dictionary definition because, believe it or not, JavaScript interviews, like I was telling you, it's all technical definitions and it's terrible. So, because variable declarations and declarations in general are processed before any code is executing, remember the two phases of execution for JavaScript, all right? Declaring a variable with the keyword var anywhere in the code is the equivalent as declaring it at the top. So in the same example that I used, like if I had var happy, it's basically like throwing. It's the equivalent to, but does not actually do, var happy like this.
What if you're doing something where you're, again, like you're changing happy to a different meaning depending on what method you're calling on, and then if it's placing them multiple times?
It's just doing this, var happy. It's not assigning any value to it. So this also means that a variable can appear to be used before it's declared. That's basically the phenomenon of hoisting. This behavior is called hoisting. Cool. So the function keyword also will hoist. So what that means is, if I have a function here, right? Function, Mike Jones. Yo, Mike Jones, right? What was his number? I don't know, but he put a phone number in there.
281-330-80.
Wow. Yo, Mike Jones. Yo, so all right, just some background. Mike Jones was like a rapper back in like the early 2000s, and he literally put his cell phone number in a song. And so people would just be like, yo, hit me up, yo, Mike Jones, 281-330-08004. And people would text him because they just put his number out. But this is also back in the day before unlimited texting. Homeboy's phone bill was like $3,000. And like texts were like 10 cents a piece. It was crazy. But anyways, the idea is that functions will also hoist. So if I were to console log and see, hey, what is Mike Jones? I should see something. I'm asking for the reference to the function. So with var, it will see the variable, put it in memory, but with the function keyword, it will actually store the entire function in memory. That's why I can actually see the whole function. So function keyword hoists, var hoists, let and const don't. Let and const are not block scoped. And var can be reassigned, redeclared as many times as possible. Let can only be declared once, reassigned as many times as possible, and const can be declared and assigned one time. Now you're all masters of var, let, and const. Those are the weird things about them. Do you feel better about the difference between the three? Why would you ever want to redeclare something? I've never had to redeclare something, but it's available to you. I don't know. That's actually a very good question. I don't know. I've never used it. I've only ever reassigned. Cool. All right. So, cool. Let's move on. Any other questions? How do you feel about hoisting? Cool. So it's very important that when you're like in these interviews, if someone's like, "Hey, talk to me about hoisting," if you say it moves your code up, the person will be like, "Okay, okay." The key is just it appears to move it up because of the way JavaScript will execute your code in like a read-only first and then an execution, so that it's stored in memory. That would be like the right answer. You don't need this like textbook definition. Cool?
In the labs, it said that you shouldn't really use var.
You shouldn't, no.
Because it's dangerous for the possibility of
Not necessarily redeclaring, it's more like it escapes the block. So like weird things can happen if you're using var. Yeah. Plus, the idea here is that you can redeclare it as many times as you want. So like at this point, you've been generally, you or another person have been the only person to work on your code base. And the beauty of working as a developer, bless up, is that you can work remote. And so the nice thing is that your team could be 7, 8, 9 people. You're all working remote. And then it's like, oh my God, what a great variable, your boy. I'm just going to put var your boy. But then your friend is going to be like, oh my God, you know, be a really good variable name? Your boy. And they put var your boy. And your code will run no problem. But it might have weird effects because which var your boy the function is referencing could be different at any time based on how you've written the code. If you use let all the time, it'll simply say, oh, you can't use let. Somebody's already used it. Just like, oh, Evans, of course you would use that variable name. And so having the ability to redeclare as often as possible, like you're saying, could have adverse side effects. So that's why people have stayed away from var, and that's why it's recommended to use let and const, and it's block scoped.
Right, and with var was the only way to declare constants before.
var was the
And
only way.
So how did you declare constants with var back in the day? Did I just capitalize or no?
Yeah, you just capitalized them, yeah. var was the only thing we had back in the day, back in the dark ages. 2015, yes. It's tough time. Back when Twitter would still fail, you know, the fail whale. All right, cool. Hoisting, we're good? Gucci fam? All right, eat. Eats for cheats. I'm so stupid. All right. Cool. All right, so here's another thing. First class functions and closures. So this is the definition, right? Anything you're going to look up now, it's not the Ruby docs. It's going to be off MDN, the Mozilla Developer Network. And so a first class programming language is said to have first class functions if a function in that language are treated like any other variable. So what that means is a function is basically like any other variable. So if I had a variable like cool object, I can do this. I can just store it into a variable. So if I do something like, actually let's get rid of this. We're done. We're past var, right? Past var. Trash. So I can use const as well. And if I put const, right, mega cool function, in theory, in a first-class programming language, I should be able to just store these functions in variables like this. Boop, function, boop, boop, and just put console log eat, right? Eats for cheats. Cool. And so the idea is that I should, in theory, be able to just look at it. This should exist. This should work. So let's take a look. Boop. And there it is, eats for cheats. It's just being stored inside a variable. So if that's the case, in theory, mega cool function, if we take a look at it, right, what was it? It's just a reference to a function. So if I have a reference to a function, can I just, bloop, can I invoke it? And there it is, eats for cheats. Coming in hot from line 38. So powerful. JavaScript's so powerful. Also really dangerous. Like you've never seen this before, right? Like in Ruby, you've never been like method, right? Just, and then just be like, yo, got you, fam. Death, cool method, right? You've never done that. So Ruby doesn't let you do that. Cool. You can't like take an entire method and store it into this object. All right. So who's feeling all right with like this first class function thing? All right. So sorry, I'm jumping around. All right. So if this is just a regular object, functions are objects, right? I can do something like a string. Cool object is a string. Lies. And then I had a function, right? And this function, oops, function took a argument, and then I put in arg1, and I just wanted to console log arg1. No problem, right? So I can do took an arg and put in cool object, all right? There's nothing crazy so far, right? If I look here and see that, oh my god, this is literally just an object. This is just inside a variable. Could I, in theory, put in cool function here? Mega cool function. Yes, it's just a variable. So if I were to console log what the argument is, what should the argument be? What is arg1 on line 43? It's a function. arg1 is a function from line 43. Any questions on that? I need to like, it's got to scaffold this bad boy right in there. Yeah.
So how is the constant going up if it's not being?
Oh yeah, this is my fault. I'll just loop. There we go. Cool. So if I put this function, it takes an argument, just one, and I passed in a function, what would arg1 be?
Yeats for cheats.
Is it yeats for cheats? It's a function, which means that if this is a function, what is 44? Is it a function that's being invoked, or is it just a reference to that function? It's a reference to that function. So if it's a reference to that function, can I invoke it? Yes, I can. If I pass in a function as an argument, that means that this function is going to call this function. So took an arg is going to accept a function as an argument, and it's going to invoke it. So far, so good. Can I invoke arg1 without took an arg being invoked? Just like in this sort of scenario. Will arg1 ever fire without took an argument firing? No. Which means that this function must come first. This function invokes this function. So if I'm passing a function as an argument, this is what is known as a callback function. Any function that is taking in a function as an argument and then invoking it is a callback function. Cool? That's a callback. That's it. Any other questions? All right, so let's go back to that powerful definition. So first class functions, right? In a language, a function can be passed as an argument to other functions and can be returned by another function and can be assigned as a value to a variable. Who feels good about this? It's just functions can be stored as variables. And anything you do with a variable, you could do with a function. Cool? All right. Cool. Cool. All right. Let's talk about these callbacks. I'm going to use a very simple argument since it's so much easier to see. So I'm going to get rid of all this. So it's so much easier. I'm just going to have function fun1, all right? And this is just going to be console log fun1. So far, so good. Function fun2. Right, and this is just going to log fun2. So all these functions do is just log, right? So if I refresh, I have fun1. I can run it, and I see it. And then I have fun2, and I can run it. And it's purple, because I added like this color purple. I'm not blowing any minds right now, right? It's just two functions, cool. So let's do this. Let's just store this one into a variable. So how would I do that? Right, const, right? I'm gonna call this CB for callback. If I've named this here, I do not need to name this. Right? So how would I do that? So what did I just do right here? This right here is just what is known as like an anonymous function. Right? This function has no name, but it does because of the variable. So if I were to take a look at what is CB, it's just a function. But notice that there's no name here. Cool? So CB can be invoked. So far, so good. So fun1 takes an argument, right? A callback function. That's what it wants. It wants a callback function. And then all it's going to do is it's going to console log the callback function. So if I do fun1, what does it need? It needs an argument, right, of a callback function. So if I put CB here, what happens? Is function1 being invoked? Yes. Right? And when it gets invoked, it takes an argument. And all it's going to do is log that argument. So what should I see? You should see fun2, the function fun2, this function. Nothing wild, right? If I were to invoke this function, what would happen? Because remember, it's just a reference to a function, and I can invoke it. What happens? Fun2 gets called. That's it. There's nothing wild, nothing crazy.
What is the use case for this now? How does this get applied?
The idea here is that fun1 calls on another function. JavaScript is an event-driven language, and so I have to wait for an event to happen, and then I want it to do something. So we talked about that Twitter example, right? I have to wait for the scroll to happen, and then I want to invoke a function that grabs the tweets and puts it on the page. So I can't invoke the function that grabs tweets and puts it on the page until the scroll happens. And that scroll is a function. So if I'm listening for when the scroll happens, and the scroll happens, then I can call another function. So callbacks were basically just designed because JavaScript is event-driven. Does that answer your question?
Can you try a simple example, like you like code out or something?
We will be doing a million of them tomorrow, but let's go into it, right? And so here's a very good, like, not so contrived example, right? We have an array, right? Obviously, these are like my favorite numbers, so they're not my favorite numbers. How do we do a for each in JavaScript? For each JavaScript. Is it a for loop? Wouldn't it be nice if there was some sort of method called for each? That would be delightful. That would be delightful. You guys haven't seen for each yet? No, the pre-work is just really good, so just really good. Powerful, yeah. All right, let's go over then. Cool. So we have an array. Oop. All right, and instead of each, you're just something called for each. Cool? And it takes in a callback function. Cool? So I can do one of two things. I can either write the callback and pass it in, or I could be cool guy smooth and I can create the function on the spot. So instead of passing in like CB or something, I can literally make the function right here. So I'm just going to put function. And don't forget this bad boy. I got to close it up. Bloop. And all I'm going to do, right, is remember this function is going to go through each of the items in the array. So this function must know about each of the items in the array. So I'm going to call this element. It's going to receive an element inside this callback. So far, so good. All I want to do is console log the element, if you want. And that's it. So I can make a function, all right, that's called print everything. Oops. And all it's going to do is console log. Well, this has to get something, right? This needs to receive something. So it needs to receive an element. And if I console log the element, what is this here? Am I just simply declaring a function? Am I invoking it? Or is this a reference to a function? I'm just declaring the function. I'm not doing anything. I'm just naming a function. So if I were to take an array, 1, 2, 3, remember, for each takes in a callback. That's the first argument it asks for. It's the first argument it asks for. That was weird. Do I have a function that I can pass in? Right, I can simply do print everything and run. Please tell me you have questions.
So in the original one where you pass an element to the function, I sort of get how it's pulling it, but not exactly. Just is it anything before the for each and say right through one by one?
Yes, here's very close, right? So here's why callbacks are important. So callbacks essentially mean that one function will invoke another function, right? So if I want to go through everything in this, right, I'm calling a function called for each on the array. But what do I want to do with it? I now need to write another function to tell it what to do with each one. So this for each, even map, right? If I were to do the exact same thing, all right, JavaScript's great. I can map it. Powerful. Except it won't really do anything because it just console logs, right? Like map's not going to do anything. Map's normally like a one-for-one transformation. But with console log, what should I get? I get 3 undefined. Why? Console log returns nothing. So if it returns nothing, it should probably then return undefined. So let's walk through what's happening. I'm doing a map, which is the same as Ruby. It's a one-for-one transformation. For each one of these things, I'm going to run this print everything. And what print everything does is it takes an element, so 1, then 2, then 3, and it console logs the element. So you actually see the console logs running. But console log returns what? Console log technically returns undefined. It doesn't really do anything. So if I'm going to map 1 and I return undefined, what does 1 become? And then what does 2 become? And then 3 becomes?
So then would you return?
Yeah, if in this it said return like 7, it would just be 777.
Right. You can return L and then return 1, 2, 3.
Yeah. So this is a very quick and dirty example. And so here are some questions that should be on your mind. And that is, print everything is declared here. Print everything. Reference to the function or being invoked? Who says reference? Who says being invoked? Okay. All right, let's take a look here. All right. Do you see the bananas? No, so it is not being invoked right here. What is invoking print everything?
Just refer back to it and have this.
Inside the map function, it receives an argument. Inside the map function, it receives an argument. And then inside the map function, it will invoke that argument. And so let's take a look at our very good example. This is map. Map will receive a callback function. Inside the map is where it will be invoked. Inside the map is where it gets invoked. So let's actually build out this for each so you can see what's actually happening. So instead of for each, let's do this. Let's do this. Let's do a function called my for each. Right? This is like ours, our custom one. Cool. What does this thing really need? What argument does it need? It needs the array, and what else does it need? It needs the callback function, right? So do something, right? This callback function is going to do something. It needs to know what to do, right? So it's going to receive a callback function. It's going to receive a callback function. So far, so good. So now, how do we go through every single thing in an array? For loop, right? The for loop is just going to go through the array. So I see this array. I'm going to change that out. Disgusting. Get out of here with that. All right. And what is the array that I want to go through? Right. So R. And then what is this right here? What do I want to do with every single thing in this for each? That's right. So I want to do the callback function. And inside the callback function, what am I giving it? The array at the key of I, at the index of I. So the way this will work is if I have an array and I call, oh, actually not really. I just run my for each and I pass it in the array, which is 1, 2, 3. And I pass it in a callback function. I can either define it right here or I can define it like what does CB do? It just console logs? Great. If I pass in CB, what will happen? I'm probably just going to get 3 fun 2s. Who understood that? I'm going to get 3 fun 2s. Great. So the idea here is if I didn't want to pass it in a callback function, I can define it right there in the line. So I can do a function. Boop, boop. Okay, take a look at this callback, right? The one that I'm passing in as an argument. How many arguments is it being invoked with? 1. It's being invoked with 1 argument. Do I give it an argument? No, so I must give it some sort of argument, right? What is the argument that I want to give it? It's probably going to get some sort of item from the array. The array at an index of I every single time. So it's getting some sort of number in this case. And then I can just, I don't know, return num. Actually, you can't do return for each. Just console log. It's weird. Num plus 1. So in terms of callbacks, it's a function will invoke another function. So my for each will invoke the callback. Yeah?
Where are you calling for each? And there's like my for each,
I'm calling it right here with this parentheses. Yeah? So I'm defining it, and I'm just calling it right here. So, callback functions. They get dicey, but they get very powerful. Who feels better about callback function? Who feels like they understand what a callback function is? What about you in the back? Okay. All right. It takes a long time, right? That's why you want to go with really, really small examples. That one function is just invoking another. And then this function is going to invoke the callback. So this function takes in a function, and it's just going to invoke it inside. Yes, absolutely. So remember, this right here, this is the callback. I'll show you. Ready? Bloop. All right. Function. This is the callback. Cool. All I'm doing is just ripping it almost one for one, and it's just that straight console log. So check it out. In the myForEach, right, you have an array, and you have a callback function. So far, so good. So for each one of the things inside the array, you want to do something. In the for loop, you want to do something to each of the items in the array. So what do you want to do? Well, it doesn't matter. You're going to pass in a callback function. That function is actually going to do something on the array. Now, it needs to do something to each of the items in the array at a key of I, at an index of I. So we can see that the callback actually receives an argument. In the callback that I've defined, does it receive an argument right now? It receives the array at I, which we know right now is like a number. So I can say that this callback should receive some sort of number. And all I want to do is like add 1 to it, whatever. It's like kind of worthless. So I can simply pass in, this is the callback right here. Which also works because the function keyword hoists. Notice how I'm using it before it's declared. JavaScript's weird, I know. The first 2 days are just like, and then you get into the DOM, you're like, oh my god, this is great. But this is like important to know. Cool? So, callback. This is a reference to the function. Notice how I am not invoking it here. What would happen if I invoke this function right here? It would kind of break because this function being invoked right here, it would essentially be this callback function. Remember, the callback function should be a reference. If I invoke it, what happens? Well, let's do this. If I return yes, what happens right here when I invoke it? What does this return? It's the same as passing in yes. If I pass in yes, it's going to go, oh my god, let me do this for loop. And then it tries to do this. Can I invoke a string yes with an argument? No, that's what's happening, and then it winds up breaking. Cool? So when you do your callbacks, it should always be a reference to a function. Cool. All right. Yeah, you can pass in a reference to the function, or you can just write it right here in the middle of it and just go, here's the function that you want. Here's the callback that you want. I define it right here. So I can pass it in, or I can create it in line. Cool? All right. That's really about it. But functions can return other functions. So you've seen that I have an outer function, and I can return an inner function. That's nothing wild. So how is this useful? Well, before I get there, so there's like a term, mathematics and computer science, something called higher order functions. Higher order function does one of two things or both. And that is it takes in one or more functions as arguments, or it returns a function. So this outer function returns a function. So this outer function is a higher order function. If you take a look at the outer function and I invoke it, what does it return? If I simply invoke outer function, what does that return? It should return another function. So then I can invoke that as well. So you can just double bananas that bad boy. It is crazy, yeah?
Why would you do that?
Why would you do that?
Why would you double function?
There's a lot of good reasons for that. If you want to pass in arguments as a callback, but we'll see. All right, here we go. You like that? Yo, dog, I heard you like JavaScript, so I put callbacks in your callback so you can call back while you call back. Very good. The idea here is like one of the most powerful features of JavaScript is the fact that you could do this. So if I had a function that says multiply by n, whatever number that is, and I have some sort of number, I can return a function that takes in a number and just multiply whatever outer number it is by this inner number. So if I did multiply by 10 is a variable. So what is multiply by n passing in 10? What should that return me? What does this return? What does this return? What does it return? Come on now, help me out here. What does this return?
The function. No, I know it.
Yeah.
It returns another function, which I'm then storing into a variable. And I've set the outer number to be 10. That means that this function will be 10 times whatever number. Because remember, 10 goes in, 10 goes in, 10 gets set here. And it's another function that has 10 times n. So multiply by 10 is a function that returns anything by 10. So if I do, remember, multiply by 10 is a function. So if I invoke that with 5, it's going to be, this is 5. And it's stored the original 10 that it saved from here. So I can have what is known as like function factories. I can do so much more by returning functions that are modular. I can do whatever I want with them by passing in multiple arguments, by returning more functions. Yeah.
Can you like invoke it twice with the numbers inside or anything? Like
Yeah, if I put 10 and then another set of bananas with 5, it'll work.
Okay.
Yeah. Cool? Multiple by n, 10, and 5 with 2 bananas, 10 and 5.
The second one will be the end, right?
Yes, the second one would be the end, correct. And so, cool. Let's talk about closures, and then I will allow your brain to relax because this lecture is like, it's kind of dry, but there's a lot of like powerful information in here. It'll be more fun the rest of the week, I promise. So, a closure. This is probably the number one JavaScript question when you're interviewing, and that is like, what is a closure? Cool. This is the freaking definition from MDN, and I'm going to explain it. A closure is the combination of a function and the lexical environment within which that function was declared. That sounds like a bunch of mumbo jumbo. I just basically have a function closure, and it returns another function. Notice how I have this variable cheese here that is referenced inside the inner function. So a closure is a combination of this function and the lexical environment. So if you've played like Scrabble or anything, like lexicon, what does like lexi mean? Yeah, lexi is just like sort of, I think like Latin for like word. So the lexical environment, the word environment, meaning what are the words inside the scope of this function? Well, you have a variable cheese. So a closure is the variable cheese and this inner function. So this function closure, anything inside of it is considered the closure. Anything inside of these curly brackets is considered the closure. That means that the variables that are declared inside and the function that it returns. Cool? So how is this helpful? Well, inside here, right, outer num, that is given to you by the user. Outer number is set when it's first invoked. So the closure here is outer number and the function that it returns. Cool? All right. So basically you have one function that can create so many different functions. So you have like one function to rule them all. Look at this science gif over here. Science. Math. Cool? All right. Are there any questions on what a closure is? Who feels like they understand closure? It's kind of dicey. No? Yes? No? You're just looking at that gif? Here you go. All right, closure. Thumbs up, thumbs down. Let's get iffy. Okay.
I know how it works, I just don't, I can't see it first, so apply it.
This is like a very contrived example, but this is the idea behind the closure. You will start to see this way more in your DOM manipulation. When you're like listening for events, you'll start to see it. We'll use
Just a block essentially is the
this function scope.
right.
That's it, yeah.
Okay.
Everything inside there, yeah.
Alright, I thought maybe.
It's not that complicated, no.
Right, when they go to different parentheses, you're just going further into sort of like a nested
Yep.
blocks within.
That's correct.
When is a block of code that contains a function not a function? Does that make sense?
It does make sense and never. If it's inside like a block or anything inside that block would be considered that it's enclosed.
So does that have to close the entire function?
This one, you can say the first closure is here, and then the second closure is here. God bless you. All right, how do you feel about scope? The difference between scope. Remember, JavaScript is outside, like inside out. All right, it starts from in, and then it does this like lookup to the outside. Cool. What about callbacks? How do you feel about callbacks? It's just one function that invokes another function. That's not one of the choices, but I understand what you're saying. Great. All right, that's all I have for you today.